on this computer. All right, you can now all give us your wise comments. How's it, Mick? You follow that? My personal opinion is, I'm afraid, it's all wishful thinking and gobbledygook as far as I'm concerned. If you can't measure it, see it, observe it, do something with it, I'm not quite sure what the point is. Even when they talk about level 1 multiverses, if you're they never address the flaws in the logic they're talking about. I mean, you talk about a multiverse that's infinite, which fills a certain space in one place, and another one that's infinite next to it, even if it's outside it. It fills. Now, if everything is infinite, there can't be any place for something else, and I'm afraid for me that's the definition of infinite. So I just have a huge problem with a lot of this.
I have a problem. I think it's moving the goalposts. As one theory gets a bit of it, they seem to spend a lot of time fighting amongst themselves about their particular thing. And that's just moving goalposts. I don't think you'll ever get to the end. After all, it's infinite, isn't it?
Yeah. Peter, you seem to like the multiverse theories.
Yeah, Derek, I always have done. If I may just say, and it's more of a statement than a question, I do apologize for that. But I think the saddest of all principles is the statement that somebody or some people have made that they will not follow any theories that cannot be disproved. And I find that very, very sad.
Yeah, perhaps they feel it's a waste of energy to talk about something which is, total speculation. So yeah, I mean, sure, I'll listen to it and I'll think about it and I'll think how it can work. But when I can't envisage any possibility of how it could work, it's really difficult to regard it with any serious,
that was quite interesting.
Yeah.
The most interesting aspect is the creatively outrageous theories that have been proposed.
Yeah.
It's just amazing how completely different people can think. And as such, one must listen to it and take note of it. But in the final analysis, if you cannot make an experimentally verifiable prediction, you have to discard the theory. And string theory is one example. And most of these esoteric suggestions come up with mainly mathematical concepts, but they don't make experimentally verifiable predictions. And I think that's where they fail. So it was interesting. It's a nice overview of the creative or outrageously creative thinking, but I will stick to more practical stuff, more measurable stuff.
Look, I do believe there's stuff that we just don't know how it works or how it exists. So you've got to consider everything. But if you can't describe it mathematically, physically, and so on, and it becomes a bit difficult. So yeah, the breakthrough is in finding ways to pin it down, to describe it mathematically so that you can predict other stuff that can happen and then prove that it happens by doing things to make it happen, using your formula. Go ahead, Peter.
Yeah, I just wanted to say on that very subject, if you can't describe it mathematically, until we have the theory of everything, is it possible to describe it mathematically?
Exactly. So we need
to agree with that, Peter. I think the next major breakthrough, really fundamental breakthrough, is when we do marry quantum mechanics with general relativity. Throughout the whole video the tension between the Bohr model or Bohr interpretation and classical mechanics measurements was visible. So until we got a unified quantum gravity description, then I think we'll get pretty close to understanding most things.
Yeah, look, we live in very interesting times. I think what with the James Webb telescope finding new things almost every week or almost every day, in fact, which don't quite fit into the standard theories, I find that very refreshing, and I think that's fantastic, because there we are actually observing stuff which doesn't fit into the pattern that we thought was the right thing. So yeah, I've definitely got an open mind that, you know, what we know about the universe is just a small part of what there is. I mean, you know, according to the theory, we only know what 5% of the universe is anyway, you know, so we're already there anyway. I still believe personally that gravity is not I mean, it isn't a force. I believe it's an emergent property which emerges from other stuff. We've got to find out what that is. When we crack that, then we can start working on the universal theory. So yeah, I think, I mean, how many times have we heard it said that there are actually no particles? It's all waves. Particles, what we see and experience and observe as particles, are really just a special kind of wave. And to me, you know, I think we just need to concentrate more on that. I mean, I think, you know, you've got the basic size of the Planck length as being the fundamental smallest length that can exist. Now, based on that, there's some. I believe there is one fundamental property in the universe which different things happen to create all the different apparent particles, and then creates the universe, all vibrating at different frequencies and having different energies flowing through things in different directions. But it's all a single fundamental particle. In fact, I think the universe at its most fundamental can boil down to two properties, and you can describe them with a 0 and a 1. In fact, and so that last bit that tonight's video ended up with, where everything might just be mathematics, in fact, could be solved by that concept, where everything is actually zeros and ones just combined in different ways. So yeah, I do believe a lot of this, what he said. I do have a big problem with the logic of a lot of it as well. Yeah.
Derek, interesting comment. I think just two more that I want to add. The one is we discussed it at the previous video already. If we think about the origin, the Big Bang, and what happened before, the term statistical fluke was used in the previous video, as well as maybe in a slightly different form again tonight. So I think it almost inevitably points to the fact that we cannot be the only universe. So it semi-automatically points towards multiverses. And it brings me back to the definition of scientific method. You develop a model, which is not yet a theory, the Bohr's model of the atom, and you make predictions which can be experimentally verified, and then depending on what you measure, you either convert your model into a theory or you adapt the model and retest again. So the scientific method, which was developed by Galileo in 1600, is still very much in vogue. and the way to go, but in a much more sophisticated and expensive way. But it was an interesting session. Thanks a lot.
Yeah, I did enjoy it, but yeah, I thought it was very complex. Go ahead, Peter.
Yeah, at one stage, he was talking about the cyclical universe, and he brought up entropy. Are there any comments on that? Because that was a very interesting part of it, I thought.
There have been some recent new information on entropy, and I've just seen 3 or 4 titles of videos by what's the lady's name? Sabine Ossenfelder.
Yes.
She's got a few things on entropy where she says entropy is wrong. It was like the headline of the video. Now I just haven't had time to look at the video, but it's definitely
It's actually quite interesting.
Attention-grabbing headline, that's for sure. So I'd like to go and have a look at that. So I think maybe she's got a very insightful view on that. I'd like to see what she has to say, but I haven't had time yet. So
She's always got her own views, and I think that's great.
Yeah. All right. I think there's so much to learn and so little time. So let's hope we can find all the shortcuts where some genius comes up with all the quick answers for us. All right.
Surely you can't have so much and so little time. Surely time must go on forever, so we've got plenty of time.
Well, fortunately, I believe time doesn't exist, so it's not a problem.
Not for me. That was math. They use a lot of new maths when they use space instead of time, and saying the factor of time is 1. I was reading an article the other day.
Yeah, just never forget what Einstein said and what his theories say. According to Einstein, you cannot separate space and time.
Yeah.
Sorry, say that again. You cannot separate?
You cannot separate space and time.
Oh, yeah.
Essentially, it's an essential ingredient of all his relativity theory. So, to me, much simpler. Just forget about time. It doesn't exist.
How can you separate them, Derek?
It's not necessary to separate it if it doesn't exist. All right. We still got some
short answer here.
All right, now, okay, Franz, he hasn't made comments yet. All right, anybody got anything else?
I was just following your conversation. It was very interesting. Thank you very much.
Oh yes, thanks for joining us. All right, and I see what is his name again from Berlin? Has left us. Yeah, he probably had to go. Okay, thanks very much for that attendance there. One of those very controversial subjects, but it's just, it's one of those things where you actually really need to spend hours analyzing various aspects of the whole thing. It's just not enough time to discuss it all. But I think to summarize, actually, this video was a very good summary of all the multiverse type angles throughout the history of science. And I like the way they put together the history of it always in every video, where they pull together the history of the various people that through the ages have come up with various concepts and so on, and put it all together in one video. So yeah, from that point of view, it's very useful. These are a lot of these are concepts which we've touched on in bits and pieces here and there, and sort of focused on aspects of it. But it's very good to look at it holistically, as this video does. I think that's what's good about this series of videos.
Yeah, thanks very much. Very good.
All right. Thanks everybody for attending. We'll see you next time.
I had hoped that we would get a better attendance tonight, Derek, particularly after sort of giving it a bit of a try in describing it. But I do feel, sadly, again, that some people shy away from controversial subjects. So what can you do?
Yeah, so the next title is What Happened to All the Neutrinos? It should be interesting. Yeah. All right.
Good night,
Okay.
everyone.
I did start doing a transcription of this thing over the weekend, but I was busy all Sunday and I didn't have a lot of time on Saturday. So I haven't finished. I've just barely started that.
Thanks again, Derek.
All right. Okay.
Thank you.
Cheers, everybody. Thanks very much.
Yes, thank you
Bye.
very much.
All right.
Thank you. Bye.